which is Romain Sacchi from actually my research group, where I am also working on. He's a tenure track scientist in the lab for energy systems analysis at Paul Scherrer Institute, and there he's working on developing two methods and tools to assess environmental and resource impacts of future energy scenarios. And today he's going to talk about edge-based impact assessment for context-sensitive LCA. Floor is yours.
Yes, thanks. So what do I need to do? All right. Yes. Thank you very much, Karine, for the introduction. Do you hear me well? Yes? Okay. So I'll be talking about impact assessment. I got to be interested about impact assessment lately because we are looking into energy scenarios and what the future might look like. And we often realize that once you get rid of greenhouse gas emission, you have other types of environmental impact that pop up. And the problem is it's hard to say whether certain emissions happening in certain parts of the world are actually an issue. They might not be if they happen in the middle of nowhere, or if we should be concerned about them. So I'm going to be presenting this work, which is the result of a collaboration also with other researchers from CIREG, University of Bordeaux, BRGM, and Mines Polytech. All right, so essentially the premise is that in most LCA software, the characterization factors are a bunch of static numbers. And when we calculate a score, we basically follow this formula. And Q is usually a vector of factors, one factor per elementary flow. It could also be a matrix, I think, in the case of Brightway. And the problem is that this is quite limiting. For example, if we talk about water footprint, we would be in a situation where we have a process in Germany consuming water. And if we follow this setting here, the factor we give to water consumption would not be sensitive to where that water consumption happens, right? And there's been some attempts to change that. Which is great. However, I think the main two attempts that we've seen is in software like CIMAPRO and I think to some extent OpenLCA, they try to deduplicate elementary flows. So when you look into CIMAPRO, you have flows called water, Germany. And then you see them being used in German processes. So you have this additional biosphere flow, water Germany, and then in those water footprint methods, you have specific factors for the elementary flow called water Germany. This works, but it's not so elegant. And most importantly, it doesn't scale because, okay, you would have to create 200 additional biosphere flow for water. You will have to create 200 elementary flow for land and so on. And also it's quite error prone. What if you forget that there is a flow called water Germany in your German process? You might miss on that. And then on the other end of the spectrum, we have tools that rely on GIS. And I think we can safely say this is state of the art, super robust, but honestly, who is expert in the room in both LCA and GIS? Raise your hand, except Chris, you can't raise your hand. Okay, Miguel. All right, 1% out of 100. So that's 1%. So I thought, well, we need a scalable solution, which might not be, maybe not as scientifically robust as coupling LCA with GIS, but at least it should be somewhere in between and easy to use. So in Brightway and other LCA software, what happens is when you calculate a solution, you create what is called an inventory matrix, which is basically telling you whenever you have a non-zero value, it's telling you there is an exchange from a technosphere activity to a biosphere activity. So there is an exchange between man-made systems and the environment. And then we multiply this inventory matrix by a square characterization matrix, which is pretty much empty, except that it has characterization factor on a diagonal. So for example, if we look at GWP, you would see at the intersection of CO2, you would have 1, and at the intersection of methane, you would have 28, and so on. So we multiply these two matrices, we do a dot product, and that gives you the characterized matrix. And what that implies is that we apply a factor of, for example, 28 for methane, no matter who emits the methane. And so what we suggest instead is to create a characterization matrix which has the same shape as the inventory matrix. And we figure out where do we have non-zero values in the inventory matrix, or where do we have an emission or a resource consumption. We apply some sort of logic, and then we go in this characterization matrix and we inject a specific value after the logic is applied. And then we do an element-wise multiplication of these two matrices and we get our characterization matrix. So what this implies is that we can apply characterization factors that are specific to an exchange instead of having a characterization factor that is applied blindly to nodes or elementary flows. And the beauty of this approach, I think, is we can also do the same for technosphere exchanges. So here, we would instead create a technosphere flow matrix, which you can obtain by multiplying the negative inputs of your technosphere flow by the scaling factor, which is the solution Brightway comes up with. And you multiply that by your characterization matrix. So now you can start characterizing intermediate product exchanges as well, which could be interesting for some indicators that tries to track metals or other kind of materials as well. This can be a bit blurry for now, but I had decided that we could go quickly through a notebook that contains examples, and I think it will become a lot clearer to you. Those who have access to the servers, that should be everyone, I guess, we could connect to the server using your credentials. So for me, it's a fold. No, it's so. Which is the address they should connect to, Chris? Okay. So for me, it's 4, but for you, it might be something else. So you'll be landing on a page that, wait a second, that looks like, yeah, that looks like this. And you want to click here. This is going to pull the notebook from GitHub. If you don't want to bother, it's fine. You can just follow along on the screen. And then you go to conference, Wednesday, edges, and here we have the notebook, and you need to select the kernel called edges. All right. And I'll try to get rid of the sidebar. All right. Is it zoomed in enough? Yeah, it's fine. Okay. So the first thing we need to be doing is to import the edges library, and specifically the edge LCA class and Brightway2 data. If you don't have a project that has EcoInvent, this second cell will kind of restore an old project that has EcoInvent in it. For me, that's fine because I already have it, but for you, that's something that might take a few seconds. So concretely, here is how things look like. I think it would be great if I could. Hmm? Okay. All right. So do not run this cell because we have some licensing issues. So do not run the cell and just look at the screen. Okay. So anyway, we need a project with a certain database. Here I'm going to use to be using EcoInvent. We are defining our LCIA method file. So we start with a very easy case. This is a Python dictionary, but it could be stored as a JSON as well. These dictionaries are fine for development. And here we basically say, well, I want to give a characterization value of 1 to any supplying node whose name starts with carbon dioxide and belongs to the biosphere matrix, and to any consuming name that belongs to the technosphere matrix. So we're not associating factors to specific elementary flows, but to exchanges that will meet these filtering criteria, right? And then we want to do the same for any supplying node that is called methane fossil to any consuming node that belongs to the technosphere matrix. We give it a value of 28. And the same for N2O, we give it a value of 265. So we declare our dictionary. We pick a random data set to look at, bamboo pole production in Brazil. We instantiate our edge LCA class. It looks very much like Brightway2 Calc because it builds on Brightway2 Calc. We do .lci to solve the system. And then we do apply strategies. So we could do manual mapping, but if the method file suggests some strategies, which it does here, by doing apply strategies, we apply the mapping strategies of those who developed the method. And then we evaluate the score. So 1.81 kilogram of CO2 equivalent. We can print some stats. And then we can generate the data frame that will show us which exchange have been characterized. So here we can see an exchange, carbon dioxide to soil or biomass stock, which was consumed by a node called land already in use, annual cropland, blah, blah, blah. In Brazil, amount, in the solution, the CF apply, and the impact. And this is pretty much what we expect. We can also look at the factor applied by supplying node names. And of course, whatever is called carbon dioxide got a CF of 1. Whatever is called dinitrogen monoxide got a CF of 265. And whatever is called methane fossil got a CF of 28. So far, so good. Now we can declare another function, but this time, well, CO2, we say it remains 1, but this time, methane fossil, we give it a symbolic expression. That's already a bit more interesting. And we say that the carbon footprint of methane is this formula and depends on a parameter called CO2 ppm. And same for N2O. There is this formula, which depends on a parameter called CO2 ppm. Good. And we select a random activity. And now we build some scenarios where we say, well, CO2 ppm, I want to try these 3 different values, and I put an H. I don't think there was a H parameter, but that's fine. And then we run our LCA. And now that's interesting because we are solving the system, and in each loop, the CFs are automatically reevaluated with the new value for CO2 ppm we give it. So it allows us to have parameterized characterization factors. Third example, a bit more complex. This time, we build a small Python function which calculates the global warming potential of a gas given its CO2 concentration in the atmosphere. I tried more or less to copy the formulas of the IPCC. So the idea is that we have, we have a function in the end that is called GWP. We have a function called, okay, that's great. A function called GWP, yes. And whenever I call GWP with the name of a gas, a lifetime, horizon time, and a given concentration of said gas in the atmosphere, it gives us a global warming potential impact. So far, so good. And now I declare my new LCIA method. And this time, I said the value is a function, a call to my external function. So now it's not a numerical value, it's not a symbolic expression, but we can call external function. Could be a Python function you've declared in your notebook, could also be a call to an API online, for example. We declare the function, and I build my scenarios where I said, well, and inside my method file, I can also provide already the parameters and the scenario I want to look at. So in this case, I took this so-called climate scenario called representative concentration pathways. And for each year, I give the expected concentration of the gas in the atmosphere. And so if I give this to Edge LCA, okay, this is very annoying. It's jumping. I need to declare my external function to say it's a function that is allowed to be called externally. Here I pass the allowed functions, and then I do a loop. And now I have my carbon footprint impact for my activity in the future across different scenarios that consider different concentration of different gases in the atmosphere. Across 3 RCP scenarios from 2020 to 2100. Okay, another example. Here we build a method that looks at water, and we say we want to characterize any exchange whose supplying node is called water and belongs to the biosphere matrix to any consuming node which has a location attribute, which is RER and belongs to the technosphere matrix. And we give it the value of 17. And we also have some uncertainty. Maybe we want to consider the different watersheds in Europe. So here we use a discrete empirical distribution where we say, when we do a Monte Carlo analysis, you can only pick any of these values because these are real existing watersheds, and they all have weights, probability weighted of being picked because it's, I don't know, could be size according to the size of the watershed. And then we want to do the same, but only for consuming nodes that are in France, but with the additional criteria that it should also have a CPC code that starts with 01, which are farming activities. So now we can not only discriminate based on the location of the activity, but also on the type of the activity. And in this, we also have some uncertainty in this case, and this is just a simple triangular distribution. We pick a random activity. No, maybe not that. Nope. Tap water production. Rest of the world is not great. Okay. Now we just do a deterministic analysis just to have a single score. 2, whatever, we don't care about the unit. We produce a data frame that shows the exchanges. So for example, for any node, any consuming node that is in RER, it gets a characterization factor of 17. This is as expected. And if we filter the data frame, if we ask what are the unique characterization factors applied, all the activities that are in Europe get a factor from Europe because they don't have a country-specific factor. And I said in my mapping strategy that if you don't find a factor for that country, apply the factor of the next containing geographical entity. And France gets 2 factors applied. Those French farming activity gets a factor of 10, and those French non-farming activity gets a factor of the next largest containing activity geography. So, and we can actually see that if we filter the data frame for French activities, we can see all those activity like wheat grain production, rapeseed production, they get a characterization factor of 10. But French activity called like treatment of municipality solid waste, they get a characterization factor of 17. And if I go stochastic, then we just say use distribution equals true with a number of iteration that can take a few seconds though. So it's drawing random, pseudo-random characterization factor from the uncertainty distribution we've declared. So of course, instead of having a single score, we have 10,000 values, and we can create a graph that doesn't look like much, but that's what we get. And then if we look at this data frame we get, it looks a little bit different. We still have per exchange consuming water, but instead we have information like mean CF, 5th percentile, 50th percentile, and then the impact also per percentile, per exchange. Next example, this one, we want to be able to characterize intermediate product exchange. So it's a technosphere to technosphere LCIA method. The method file, for example, here, I said we want to characterize the consumption of recycled copper. You know, maybe you're into MFA or these kind of things. So here I say, I want to characterize any exchange whose supplying node starts with treatment of, and reference product is copper cathode, and belongs to technosphere matrix, but excludes market. We don't want to double count to any consuming node that belongs to the technosphere matrix, and we give it a factor of 1. I do the same with copper anode because there it's copper cathode, copper anode. We declare our function. We pick a random activity, not waste treatment, not that either. Aircraft production, we want, okay, maybe 1,000 aircraft, that's going to be too much. Then we run our analysis and produce the data frame, 70 kilos of recycled copper. And indeed, when we look at the data frame, we see what are the exchanges consuming recycled copper. And these are obviously the way Equinvent is built. It's market for copper that consumes recycled copper. But at least we can track precisely which exchanges are responsible for the product, for the consumption of a specific metal. And yeah, as a bonus, you can also produce a Sankey diagram to precisely see where materials are consumed in your system. For the sake of time, I think I will skip that and go finish my presentation. Yes. Now I'm going to walk you through a few more examples which are a bit more serious, a bit more applied, not with dummy methods. So here is the case where we implemented Aware 2.0. So it's a bit hard to read for you, I understand that. But the LCIA file looks like this. So we want to characterize any supplying node called water lake in these categories to any consuming node whose attribute is location, and that equals Armenia. And it has a factor of 88.6. And within Armenia, we have 2 watersheds. So when you do Monte Carlo, you can only pick from these 2 watersheds, and they have these probabilities of being picked. So then we can get our regionalized results. We have the net freshwater use per location. We have the characterization factor applied by location with the error bars. And then we have our final score, regionalized score with the error bars. And then, of course, we compare if you don't do a regionalized assessment. In our case, you overestimate by a factor 2 the water footprint, because this is the example is to produce a kilogram of water in France, and France has relatively no issue in terms of water scarcity. Something I haven't talked about is that we're able to resolve aggregate and dynamic locations. So for example, if you have an activity that consumes water and that activity has the location rest of the world, Edges is going to look, let's say it's steel production rest of the world. Edges is going to look at what other data sets are called steel production. Maybe we have Switzerland and Sweden. So rest of the world are all the countries in the world minus Switzerland and Sweden, and it's going to compute a water consumption weighted characterization factor for this specific rest of the world activity. Second use case, technosphere characterization. Here we implemented a metal criticality indicator called geopol risk. So here, for example, if we look in the LCIA file, we could see we want to characterize any exchange whose supplying node is called aluminium production, which has the location Australia, belongs to the technosphere matrix, and we exclude certain names, to any consuming node which has the location Canada and belongs to the technosphere matrix. So here we are characterizing intermediate product exchange for a specific metal between 2 specific countries. And it allows to have analysis like this. So it's still a kilogram of hydrogen produced in France. But this time, for example, if we zoom in on the characterization factors for crude petroleum, we have specific characterization factors for the trade of petroleum between 2 specific countries. So the factor for the trade of petroleum between US and South Africa is much lower to that between Algeria and Brazil, for example. So this allows you to assess how critical your system is with respect to, supply shortage and things like this. And this allowed us to see, for example, per kilogram of hydrogen produced, iridium, we only use 1 milligram of iridium per kilogram of hydrogen, which is very low, 1 milligram. And yet it's the 6th most critical resource in our product system because it's iridium coming from South Africa, and it's associated with a pretty high criticality factor when it's imported to Europe. Another case, regionalization. Here we implemented a method that assessed the biodiversity impact via land use. So here, for example, we characterize any edge whose supplying node is called occupation annual crop to any consuming edge, which location is Afghanistan. And we have a CF, which is potentially disappeared fraction of a species. But when we go stochastic mode, we are listing the different ecoregions in Afghanistan. So when we do a Monte Carlo simulation, not only, we have the factors for Afghanistan, but then it's going to pick random ecoregions within Afghanistan because we might not know precisely where our process is happening within Afghanistan. And then we have this error bars per type of biome being affected by land use. And here we compare the regionalized score, which is the median is slightly higher than if we used a global factor. And of course, the error bar is quite high. For example, the mining of iridium in South Africa has quite a large error bars because depending where the mining is happening in South Africa, the impact on biodiversity can vary a lot. And last example, and then I'll let you be, is the use of scenario-based characterization factor. So in this case, I reuse an indicator from Recipe 2016 called fossil fuel scarcity. And it's an indicator that tells you in dollars, how much surplus production cost do you incur in the future by extracting a megajoule of a certain fuel today, because in the future they will have to dig deeper to get that same megajoule. But of course, VPCP gives those factors for today, depending on today's resource for these kind of fuels. What I did is that I looked at scenarios from so-called integrated assessment models that provide scenarios for the future. And here I said any supplying node called all crude and any consuming node belonging to the technosphere, the value of the characterization factor is a symbolic expression made of the marginal extraction cost of said fuel, the annual extraction volume of said fuel, and a discount rate. And then I extracted these three parameters from those future scenarios. So for example, you can see for three fuel here, coal, gas, oil, we have the annual production across three climate scenarios. So in a not so ambitious climate scenario, of course, extraction of coal goes up. But in a climate ambitious scenario, those type of fuel, their annual production tends to converge towards zero. And so once we have these parameters in, we can do the LCA of our kilogram of hydrogen, and we get the final score over time across the three climate scenarios. So this could become quite practical for prospective LCA. Limitation, well, that will not replace any site-specific impact assessment. So if the use phase is very important and you expect the impacts to be very sensitive to the precise location where the process is happening, then you might even not be wanting to use LCA at all, but more like impact assessment tools. And of course, this is as good as the inventory data you have. If you, for example, if you want to use regionalized impact assessment methods, but your inventory data is not so well regionalized, then it's a limitation. Nevertheless, I think it represents a pragmatic and approach to this flexible impact assessment. Yes, it's an accessible solution for regionalized, relational, and prospective lifecycle assessments. The development of this tool was financed by ADEME via the HiSpy project, so we thank them, and we have a paper describing the tool that was published recently. Thank you very much.
Thank you very much, Romain, for these insights. I hope and guess this will have triggered some questions or comments. Does someone want to? Yeah.
Thanks, Romain. I think this is fantastic development. Thank you very much. And my question is, where do you see this going forward? What kind of methods would be next in the pipeline? How would you like to see the community participating in this?
Yes, I mean, personally, we are interested in certain topics at PSI. So my priority will be to develop indicators that have to do with our topics. So that would be biodiversity impacts, so regionalized assessment of biodiversity, and also material. We are increasingly linking LCA with MFA. So with this kind of technosphere-based indicators, we can track precisely how much metal we use, how much of that is primary versus secondary, and what is the fate of these metals. And then you can easily connect that to some MFA tool. And then, that becomes quite easy to do. So I would say, yeah, MFA-related indicators and biodiversity-related indicators. And of course, because we also do quite a bit of prospective, my hope is that we can, in the future, have prospective versions of the methods we know, like Impact Well Plus, that correspond to a certain SSP RCP. So we could, if you build a prospective lifecycle database, like with Premise, for example, then you can use a very specific set of indicators that correspond to that scenario and that year.
There's someone else with a question or comment on this? Yes, please, Konrad.
Thank you, Romain, for the nice talk. So it's two dimensions, right? It's location-based regionalization and sector-based.
It can be.
Kind of.
doesn't have to be. It can be based. It depends on the attribute you set in your LCIA file to identify exchanges. It can be based also on how much of the amount is exchanged. You can discriminate the CF based on how much is exchanged, or it can be based on the unit, or it can be based on any attribute of the nodes that are at the both ends of the exchange.
So of course it's really powerful open that you can kind of characterize the exchanges with everything. But in general, for our LCA results, because EcoInvent has a similar, they also want to go towards regionalization and then also sector-wise. And I sometimes think that, I mean, we first need the tools that do that, but that it's more important to get more smaller regions to characterize than characterizing also the sector. Like I will give an example. You regionalize the water use, for example, in Spain, not global, just in Spain. And then you can have a sector characterization factor for water use in a water power plant or water use in agriculture. We'll have a different depletion factor. But still, it will be averaged over whole Spain. So in my opinion, the sector has less priority to characterize the sector than really characterizing the location where the plant is located. Because imagine Spain again, the plant is in the desert or the plant is in a city.
Yeah,
like that we should also go in that direction to have more.
Right, but for example, something I'm working on. So let's keep with that example. You could cross-check Eurostat data that tells you which industries are in which nuts region, in which European countries, and you can cross-check that with watershed data. So then you can have a characterization factor for a certain type of industry in a certain, either in a certain nut region, or you know that in Spain, X% of the water plant, the hydro dams are in this nut region and so on. So you can have watershed specific per nuts region. And then in your Monte Carlo, you'll be able to represent that.
Okay,
that's one way. But yeah, I agree. But I think, the tool can do both in principle. So I guess then it's also the job of those developing this LCIA method to prioritize what's most important.
Yeah, and for sure we should not have these flows anymore with locations attached and all these things. I mean, Michael, our lead developer, already removed that 2 years ago, I think. So at least we have already your first dimension integrated. Yep. So you can do a regionalized calculation in OpenLCA, which will calculate another matrix. And then you have all your inventories location-based, regionalized.
Yeah.
Thank you for your presentation. I had a question regarding, for instance, an example of regionalization. The characterization factors that you do not explicitly filter or decide how they will be assigned, what happens with all the rest of the life cycle? Is there some kind of default, or it will compute only what you give it?
We have mapping strategies that you can apply manually, or they are suggested by whoever builds the LCIA file. So for example, first we try for direct matches, and then those edges that still consume, for example, water, but haven't been detected, you can say, maybe it's Quebec, and we don't have a factor for Quebec, so it's going to try to apply the factor for Canada, for example. And then if that doesn't work, then all the edges that still consume water and should have received the factor, then they resort to global characterization factor.
Thank you very much for the nice presentation. I'm linking with the previous presentation from Raphael. Have you thought of the compatibility of such methods with factorization calculation methods like LCA algebraic? Or maybe it's more a question for Raphael as well. But I'm wondering if those two methods could be applied together.
Yeah, I have my doubts because this is happening at the LCIA steps, all these mapping strategies, and it could be something we need to look into if there is a need, yes. Why not?
Okay.
So you have like some of the files that you showed. I was wondering how, like, do you provide examples with the library, or are you actually also maybe looking for contributions for like, do you somewhere store like predefined LCIA
Yes.
files?
Yes, if I can show that. So if you look at, is it possible to get the computer back? Right. So we have sorry, let me try to find that back. Yes. So in sorry. Oh. Right. So we have a repository for the library, and in the repository you find all the LCIA methods we have already implemented. So you could see where these are all the JSONs, where GLAM for biodiversity, impact, well plus, and geopol risk, and some others. And so anyone is welcome to contribute with additional JSON files if you think they are worth sharing. And there is extensive documentation that explains how to use each of them. Good, thanks a lot.
That's a good closing of it. Like, let's collaborate. Thank you, Romain. Our next speaker is online. So Juan, could you unmute yourself and eventually switch on your, yeah, there you are. Thanks.
Yes.
Perfect, and we can
Thank
hear
you.
So
Perfect.
then you could also share your screen while I'm presenting you. So Juan is a research scientist at Agroscope in Switzerland and also KTH Royal Institute of Technology in Sweden. And he holds a PhD in environmental engineering, and his research focuses on advancing techno-environment assessment across diverse urban systems and circular economy solutions. And currently his work focuses on assessing the prospective environmental impacts of emerging agriculture technologies. That's what he has sent me. But actually, Juan, I like your presentation on HiHive also a lot, so I'll read it here. He's saying on HiHive, I'm an environmental engineer doing my best to populate knowledge for a better world.
Yeah, that's actually a sentence that should be copyrighted to NTNU, which is a place where I learn LCA at the first site, and then I always use this sentence as much as I can because I think it's a
one. We hear you, but the volume is a bit too slow, so we're just adjusting.
Okay.
Okay. Yeah.
Yeah. Is it fine now?
Yeah, that's perfect now. Yeah.
Okay.
Thank you.
I was just saying that this sentence is actually copyright from NTNU, I would say, where I studied LCA at some point in my life, and it's a nice sentence I always try to use as much as I can. Anyway, thank you for this introduction and for the opportunity to be here. I'm so sorry that I cannot manage to be on person. So jealous of you. But yeah, as let's say, linked to my background, let's say here I'm going to present you today as cores. This is a LCA based tool we did during some years, let's say, with Agroscope colleagues, but also colleagues from KTH, but also UAB, a bit, let's say, learned by experience, and then I show you quickly today because I have a few minutes to show you what is it, and see if you are, let's say, if you see also the purpose. So I'm going to show you only three things of this course: the objective of the tool, the structure, and then a live demo, and see. I hope it really works. It's always tricky with live demos, but basically the objective of this tool is to facilitate the inventory modeling phase in a way that we can also simplify and improve LCA workflows. It's basically about, as I said, backing up from my own experience, I think we need to really connect LCA modelers that work with primary data and foreground modelers, let's say, and the ones that we work also with Brightway and normally with background data as well, right? And normally this translates a lot in many LCA groups, that the ones that at least I have experienced is with people that really works with CIMAPRO and gets inventory data introduced in this software, and then people that really works on Brightway. And sometimes we really, I believe we really need this connection to make sure that, let's say, where LCAs that doesn't get lost at some point in CIMAPRO, let's say servers or computers, right? And of course, we are doing that because we know that the inventory phase of any LCA takes a lot of time, right? And that's why we want to also speed up this process itself, right? And apart from this inventory modeling tool, we basically aim, as I said, to face many problems that LCA practitioners currently today need to be solved, right? Which is to establish a tool that enables us to structure inventories and identify unique background data sets the same way. So we make sure that, let's say, this primary data is useful for everyone, but also a way that these people that doesn't have programming skills can have multiple outputs with only one input data. Let's say, so only one manual input data task. So then we basically try to avoid shifting results from one tool to another one, right? Which is actually it makes no sense, right? That this iterative process of LCA indeed requires merging data from many tools often, at least from many LCA foreground, let's say, modelers, right? So here, what we try to do with this course tool is basically, since our, let's say, what I thought at the beginning is that the final output we want to achieve as background LCA modelers, let's say, is to work with files that can really work with the Brightway environment, right? And that's why backing up from the Brightway output Excel files that we can import to our Brightway flows, let's say I went back to basically create an Excel-based tool that basically can facilitate the way we input data on Excel, and to get these outputs as the one here from Brightway. And of course, we are doing that with Excel because many times when we have primary data, we still need to manipulate this data to make it, to address or to calculate our functional unit, right? I mean, we need to normally reorganize it the way we get our functional unit right. So we tend to do some minor calculus before we get to the functional unit results, right? So this tool is basically made with two Excel files. One is the score matrix, where we get the impact assessment scores of all processes of all the database that we are working with, and then the scores template itself. Okay, the first one is made with a Brightway code back from EcoInvent or CIMAPRO databases, and the second one is basically your primary data that you manually input to the template itself. Okay, and here we are not trying to reinvent the wheel. What we are actually trying to do is to reproduce actually the way that normally all inventories are created. So basically putting foreground descriptions, putting some inventory data, some calculus that we need normally to do, as I said just right now, and then basically find a way to identify those flows easily and super fast. Okay, and then after this is done, we can then get impact assessment results, but especially inventory results itself, which is the main thing of this tool. Okay, let me go through the hands-on demonstration, see if everything works. But yeah, basically this is how, let's say, the tool itself works or looks like. I will just go quickly on some of the sheets that you will see here, maybe not all in detail, but I don't have more time. But basically, this is a typical inventory. As I said, we are not trying to reinvent the wheel, but at the beginning of this inventory, we normally input the data that we need. For instance, if, let's say, a tomato production in a greenhouse, that we have different phases with different subphases, basically, yeah, that can be inputted here as the way you wish. You can also add some metadata that sometimes I think it can be useful, and then you do simply some calculus normally to get your functional unit, right? So imagine that you get the primary data for 24 kilos, and then you wanted to put it in one. Typical things, right? Again, we are not reinventing the wheel. But here, the nice thing, or the first nice thing that we can see in this tool is the way we can actually look for those data sets that we want to input, right? And the way we do it is there's a simple search box where you can, for instance, look for any, let's say, production or any process that you would need. Let's say, for instance, this coconut husk that we need for this growing media for this tomato production. Then you basically can select the reference product, the location, the unit to make sure that you are doing the good thing, right? And then basically you copy paste it on this on just below, and then basically you can see here it is found in the database where we can double check that this is the right activity. And basically here you can get the CIMA-Pro process. As I said, it's an inventory modeling tool, but you can also get impact assessment scores if you need it. First of all, for instance, we can also check, it's a simple thing again, but there's a link to Echo Query in case that we want to check that if this is the market activity that we want to check. And then finally, as I said, we can do an impact assessment scores very, very quick. So basically, what Excel is doing is trying to match the process with the matrix and then basically getting the result. And then basically we will get it here. Once we have it here, we also have this result copied in this database format. So we make sure that all the results are perfectly fine and there's no misleading formulas or anything that can, modify our results. And then we can also export this database into a CSV. Okay. What is more interesting now is that once we have this, let's say, scenario assess, we can also use this functionality, which is about to expanding scenarios, because most of the times when we are working on primary data, we are also working on how to improve this primary data or this process that we are assessing, right? And then it might be the case that you need to change a specific units or specific locations because you want to do a sensitivity analysis, and then you can basically input different units in different scenarios. Once you do that, you can build these multiple scenarios at once. So again, it's about clicking one button. We can decide if we want to include LCI scores or not. Let's say no for now to keep it simple, but then we can input the 3 scenarios that we are working right now. And then what happens now is that the system that we saw before, it's basically multiplied by 3 because it contains all the units that we have for every, let's say, a scenario we are working with. Good thing for the audience right now, probably, as I said, is that we can link now this inventory to other, let's say, tools. And the one that we can link, for instance, is the Brightway. So basically, if we click this button again, that it asks if we want to include the scenarios. Let's say we also want to include these 3 scenarios, and then we go to this system Brightway sheet, and then you can see you have this standard format of Brightway with the right names exactly as the way Brightway needs, because otherwise it crashes, right? And then basically we have all these 3 scenarios with the different units for all this tomato greenhouse production, right? In case we wanted nested in one activity, we keep this, but otherwise we can also delete this part of this of the Excel file, and then these activities will be imported independently in our Brightway environment, right? Another thing that we can do as well is this, in case we want this inventory to CIMA-Pro, we can also create a CIMA-Pro file with this. Basically, what we are doing here, we can also decide if we want to include the scenarios or not. Let's put 2 here, for instance. And then what it makes is creates this Excel sheet with this format with all the CIMA-Pro names. That is actually the format that CSV Maker from 2.0 consultants need to create another to create these CIMA-Pro CSV files. So this part of the tool itself, of course, it's licensed. Of course we have the license for that, but of course we cannot publish that. You need to make yourself with this license. But in case you have this license, then it's easily to get this data again to CIMA-Pro CSV file. Yeah, so basically you can see that in few clicks and in few minutes we did our, let's say, our inventory. We create it and we bring it into with the LCA data, everything included. We also did this inventory file, but we also did this Brightway file, also created with this tomato greenhouse production, but also the CSV file ready to import in CIMA-Pro. There's also another thing that we recently included that also it's quite interesting maybe, which is we can also import data from activity browser. So in case we have, for instance, this activity browser with this different a product of a tomato, again, seedling, we can actually copy the processes that are here in the exchanges, bring it here on the tool. Let's put it here, for instance, and then basically here we can reorganize this data the way we need it. So basically, exactly. So now we have, let's say, the exchanges of this activity from EcoInvent. We can delete this. And then if we bring these units here, basically now we can modify those units as the way we wish, because we are editing some activities here to EcoInvent, and basically, let's say, expand our system with the activities that we want to edit directly from EcoInvent to the scores tool. Finally, there's a last thing that we also did recently, which is apart from working with EcoInvent databases, now we are able to work with other databases that comes directly from Sigma Pro. These databases require further integration first to Brightway and from Brightway to this tool. So it's, let's say, correctly formatted for this Excel sheet. And then we can basically do the same that we did, let's say, with EcoInvent activities, but also with other databases as well. With this, I'll finish my presentation, because it's actually, this is the follow-up of this tool, of this work that will be presented from my colleague Cedric Fourier on Friday. So he can also give you more details on this last part of this implementation of Sigma Pro databases. And that's it. Thanks a lot. I'm not sure if you're talking or discussing anything, but I cannot hear you. I'm not sure if it's your case as well. I'm sorry. No.
Hello, can you hear me?
Now I can hear you.
Okay, perfect.
I'm sorry.
The presentation, like, really interesting. Um, uh, like, really interesting to see, like, a lot of stuff that you can do with only with Excel. Um, is this tool going to be open source? And how exactly did you build the Sigma Pro exporter?
Yeah, I mean, let's say the tool itself, it's openly available. You can look at it on my GitHub directly. Of course, I can only put available the part that is not, let's say, the part that is freely available without any license, let's say. So the names itself of EcoInvent, this is no problem. And then, yeah, but of course, for the rest of the tool, you need a license from EcoInvent. And then, yes, we use Sigma Pro export function to get all the rest of the databases that are not EcoInvent, so we can integrate them in our workflow as well.
I have a question. Thanks a lot for your tool. What made you choose VBA? I've worked quite a bit with VBA, and I think it's not the easiest language to use, not because it's a complex language, but because what works on the Mac doesn't work on the Windows computer. And what works with a specific Excel version will not work with another version. So have you thought a bit about, do you have a plan for the future for the maintenance of your tool?
Yeah, I mean, at the beginning, as I said, our focus was on those LCA practitioners that really don't have programming skills. And that's why we thought that Excel was a good starting point, in the sense that many, if you ask to everyone that is working with inventory data, the starting point is always an Excel sheet where they can do those calculations prior to get the functional unit, right? Inventory flows. And that's why we stick to Excel. It's true that Visual Basic is a terrible language program, I can tell you for sure. So I try to, let's say, to solve as much as I can from my side. I think, let's say, I'm quite sure that now let's say it works. I try to make it compatible for both Mac and Windows platforms. But of course, yeah, it has some limitations. In the future, it might be, you know, it might change to another language program. But as I said, it's difficult to also get other environments that LCA practitioners that are not used to programming skills can, let's say, can feel comfortable. That's the main issue.
Thank you.